of practical philosophy at the University of Hamburg here. His research has an interdisciplinary focus on political philosophy and includes aspects of welfare economics and political theory. His work mainly deals with core areas of political and moral philosophy, such as the systematic analysis of power, freedom, and responsibility. He has published research which is highly relevant for the symposium, such as Causation and the Measurement of Power, which was then further developed into a paper titled Degrees of Causation. And you should all have received the handout as well for the presentation, which we have here in hard copy. And we're very much looking forward to your presentation.
Okay, thank you.
Great idea.
I'm actually, I just want to say a few words here. I was making notes on the discussion, and I wanted, before I get into what I've just done, provided a small sort of Causation 101 or Causation in 30 minutes. That was quite a task when I received the request. I thought, oh gosh, causation, fine, an overview of what philosophers say about causation. And then I saw the time slot, and that was a challenge. And I really enjoyed it. I had to think for a bit about it. But I think what I have to say in this little sort of Causation in 30 minutes is going to put some of the words that Conrad was saying in a very important context. He actually was coming to a conclusion that Bertrand Russell made early in the 20th century, that causation is a completely useless term, not useless, you can eliminate causation. It's not an important concept. It belongs to the past, to the metaphysical past of philosophy and so on. We can replace causation by simple functional relationships. And we do not need to worry about what really is a cause. That is an old sort of leftover problem of philosophy before what the whole logical empiricism, logical positivism took hold. But however, thinking about what I heard in the past from in neuroscience workshops and discussions, it did occur to me over the years that in fact, when neuroscientists come up and say they've got a causal model and they don't make explicit what's the nature of the causal conception. There's a concept of causation, and there's conceptions of causation, what conception they are using. It is easy to quickly demonstrate that what Conrad was also saying is actually can be covered by an Aristotelian concept of causation. And that's what I wanted to outline, these different conceptions of causation. And his basic argument was that we should actually, maybe we don't need to get rid of causation as a concept overall, but for the brain, causation is not manageable because he's taking a particular conception of causation, which turns out to be the counterfactual conception of causation, or an embedded counterfactual conception of causation. And as he was talking, he's basically talking about the idea of capturing the entire brain through switching system. So counterfactuals, conception of causation. If you switch something on, what happens? If it hadn't been switched on, that wouldn't have happened, and so on. And I then realized what his idea of confounders are. These are simply counterfactuals in a possible world semantics. But okay, so I really would like to get to to what I wanted to say, is that if we want to see what causation can help us with in explaining and understanding the brain, let's just quickly look at the sort of classical positions. And it's important for neuroscientists actually to take this up and then be explicit about it. So there's sort of ancient origins, and Aristotle is really the first philosopher to really systematize the notion of causation for the natural sciences. And the idea basically being that explanation requires a notion of causation. And that is both for the natural, the social, and the artificial world. And he sets out basically 4 properties of a causal description. One is material cause, that out of which something is made, a bronze statue. So anyone who does art would understand that. His conception actually of causation comes very much from production, that the world in which we live in is a result of some working mechanism, in the same way as a sculptor makes something or an artisan makes something. So there's a material cause. So when we want to talk about causation, there's some stuff. Well, obviously this is the brain matter. Then there's a formal cause, which is a bit of a misnomer, actually, from what we understand, which formal cause, about the notion of formality or formalism in philosophy. This is the form. It's an account of what is to be the shape of the statue. So it's basically setting out the dimensions. The formal cause are the dimensions of the object to be produced. And then there's efficient cause, and that's this primary source of change or rest. Again, he refers to the artisan, the art of making, again, a statue, a man who gives advice. So he's taking all his notions of explanation from the world of experience. He's the first empiricist in that sense. And then the final cause, which is a kind of teleological notion, that at the end of this process, there is something that is aimed at, been dragged to, as a matter of design, and that would be the matter of design of the artisan or of the sculptor. So the final cause is that end for the sake of which a thing is done, say health, losing weight, developing surgical instruments, or making a beautiful piece of artwork, and so on. And so that's just, roughly speaking, when Conrad was saying, interestingly, he said, well, let's stop studying the brain and start looking at the process. Well, you could break it down and says, well, he's actually adopting an Aristotelian conception of causation, in which we are looking at the material cause, the formal cause, the efficient cause, and the final cause. So by simply saying we don't need causation, that's fine, but in a sense it fits within an Aristotelian paradigm. And some would say, well, that's not surprising, because relative to other sciences or other disciplines or areas of investigation, neuroscience is relatively new. And we start in the natural sciences by a process of documenting experience. And what more is it that we document is the stuff that we're looking at it, what's its ontology, what's it made up of, what are its dimensions in space, what brings it into being, and what does it look like at the end. That's a very initial part of scientific activity. The pragmatist school from C.S. Peirce, William James, and John Dewey would always say, the world is made up of problems. He's very Aristotelian on this one. In Dewey's work, How We Think, and his modeling of the scientific analysis is we start with a felt problem and we describe the felt problem as clearly and as structurally as possible. So this belongs to the first stage of problem solving. And that I would simply say is that if we would take this notion of causation, then what we're having is that what he was saying is that we should really actually put aside the complexities of a counterfactual analysis and get back to the roots of getting, first of all, the bits of the world right and the processes right in terms of a clear description. Okay, so that position about causation was really sort of dominant, and then we run right through to the Enlightenment and David Hume. And Hume simply departs from Aristotle and develops his theory of causation in two works, in the Treatise on Human Nature and an Inquiry Concerning Aristotle. But like Hume, he introduces what some people call the copy principle. Not like Aristotle, he's an empiricist, and he introduces what some call the copy principle. All the constituents of our thoughts come from experience. So briefly, all ideas, so if we have an idea of causation, is going to be the product of empirical impressions. So how the world out there impresses on my mind, and therefore, when we're investigating causation, we've got to find out again the empirics of it, and we want to see how the world works. So Hume identifies that ideas are associated to form explanatory theories in two ways. So this is an important point, is to say is that the scientific activity, or let us say intellectual activity of investigating the world, is structured, and he structures it into natural relations and philosophical relations. And then there are natural relations which are those are observable, but he then says, well, some things are not observable. For example, when we want to make a prediction, we cannot observe the prediction in advance. That is an inference. So inferences are not empirical. We may make the inference itself may be empirical, we're saying how the world is going to be, but we're making this prediction, this inference about how the world could be. And there are three kinds of relations he talks about: relations of resemblance, contiguity, and the most important, he says, cause and effect. And for Hume, the cause-effect relation is this most significant one. It is also a philosophical relation, because we can observe cause and effect in the empirical world with the example of the sort of billiard ball. A billiard ball hitting the white ball, hitting the red ball, white ball hopefully coming to stop, the red ball goes on. We can observe that, and he says, well, that observation is what we take to be the basic, covered by the basic concept of cause. And that relation of cause and effect is crucial to our understanding if science is to go beyond mere description of how the world currently is. And he wants to cover the notion of causation with a regularity. That is to say, is when we're talking about causation, we're talking about a certain lawfulness of the following form, that when all C's are E's, or whenever C, then E, that is simply saying we're looking at the world, and whenever we ever see a C, then E follows. If we structure it as follows, that the cause and the effect, or the event one and event two, are continuous in time and space. So there's an event one, and which we call the E1, an event E2 follows from it, and if E2 follows from E1, then E1 is the cause. It must be the case that the cause, this first event, is prior to the effect. There must be a constant union between them. There must be some kind of connection between the first event and the second event. There is no causation at a distance. So again, it's the billiard ball notion. And the same cause, and this is an important part, this is the regularity thesis, that whenever there's a C, an E follows. This is the notion which we say in the philosophy of science as this covering law conception. So the regularity is to be distinguished from, however, singular causation. And this is unfortunately, when Conrad was discussing this, this is then not delineated. And from some papers that I've been reading on the philosophy of causation in neurosciences, the two concepts of causation, conceptions of causation, are not delineated. One of them is this regularity thesis, which is roughly speaking what we understand by a law, scientific law, and what we call singular causation, and that refers to those relations where the relata are particulars. That relation does not exemplify a pattern given by a covering law. So, for example, well, the example is often given in the book. We take legal examples from that. That the braking train caused sparks. Sparks flew out onto the dry grass. and there's the meadow catches fire, and then there's a forest fire or whatever. Well, you cannot say that whenever a train breaks, a forest fire will break out. But you can say, under the circumstances, had it not been the case that the train would have braked at that particular position and that place, then the fire would not have occurred. So there's a distinction between making causal statements of this singular nature and causal statements of a more general nature. So Max drinking of a gallon of wine was a cause of his drunkenness, is this statement of singular causation, while Max drinking of a gallon of wine causes drunkenness is a general statement that implies this covering law. And you can see from the discussion that was going on is that distinction has not been made, and we have to make a decision that maybe when we're doing neurosciences, are we concerned about singular causation in a particular circumstance, or are we thinking about covering laws for the laws of the brain, so to speak? Now, the question is the aggregation of singular causation, does it provide you an aggregate overall regularity thesis of causation? The answer is no, or at least it hasn't been achieved easily, although the work that is being done, the more formal work that's being done, is now trying to bring those two conceptions together under a general model of causation. So after Hume, we have in the system of logic from Mill, basically Mill develops on Hume. So well, Hume was concerned, actually didn't look at the complexity of causation. Exactly what Conrad was talking about is that there's this terribly complex situation, and what he talked about confounders is that these are counterfactuals. And when he says, well, it's very difficult to model the system of the brain because there are so many counterfactuals. That's exactly what Mill was thinking of, and it's not surprising because Mill was also an economist, and he was also thinking about economic relations and political relations and so on. And in the system of logic, he says, an effect usually occurs only due to several factors, that is, events that are instantiated, event types or particulars. So these may be positive or negative, and the cause is taken to be the totality of them. So basically, there are these positive causes, and there are those which are countervailing, so to speak. So there's C1, C2, C3 can produce E, E, the event that comes about. But if D1, D2, or D3 were present, then E wouldn't have come about. Those are the confounders. And that's what Conrad was also talking about. We were dealing with confounders of different neurons or neurological, let's say, processes, which can confound some neurological process, or that neurological process could take a different trajectory, which would be one of the neurons would be a confounder, so to speak. So basically, we're looking at the same thing, but Mill was saying, okay, what we have to do is that we say that there is what causation deals with is the types. There are events, C1 to Cn, that produce E contiguously, but D, the confounders in that language, or the counterfactual alternatives that are not, let us say, switched on, D1 to Dm, are not present. And it is a law of nature that an instantiation of all positive factors, followed by the instantiation of all negative factors, give us the outcome E's. So whenever we have all C's and no D's, then we have an E. And that is the conception that he says, well, you just have to expand the causal conception from the conception of causality from Hume to take into account that there are other countervailing activities or forces, if you want to say. Now, this approach gets picked up in the 60s and in a paper in the 60s, but it's referred to from the book from Mackey. Mackey, a Oxford philosopher, defined, he said we shouldn't really talk about a cause. We should talk about causal factors, causal events that contribute to an outcome, accepting that a single event is not always sufficient, it's not always necessary, but what it may be is that a cause may be insufficient, but non-redundant, part of an unnecessary but sufficient condition for E. That whole alphabetical jumble is simplified later by a legal scholar, Richard Wright, into what's called the Ness test, necessary element of a sufficient set. So there are two aspects to it. He just simplifies the language of it, but he also simplifies the formal structure, which I don't want to go into, there's not the time for it, of the Einus conditions. So Mackey sets out 4 conditions, and Richard Wright points out that one of those conditions is going to be a problem, and there's a slight difference, let us say, in one of the conditions that he sets out. So basically, again, I had the sense that Conrad was moving towards actually the recognition that we need a kind of Einus or Ness condition, because Mackey then says, well, look, we take this Humean million account and we have to deal with one particular thing. It's going to get too complex. There's too many C's and too many D's. What we want to do is reduce those C's and D's that we do not require for explanatory purposes in a particular instance. So now we're seeing he's bringing a regularity and singular causation together by introducing what he calls the causal field. And the causal field is the background conditions. So when we look at the braking train caused the fire, we are simply assuming the presence of oxygen, because oxygen is a requirement for combustion. Now, this is very, very important here, is that to recognize that what Mill and then Mackey and Wright are trying to do is they're looking at a conception of cause, which I haven't written down here, as difference making. Would the events that take place make a difference to the world? And if we would place it under a covering law conception, then we have a regularity thesis, but we can also apply this Einus idea to a specific singular case. And the Ness test, and the in particular necessary element sufficient set, has been developed in legal scholarship, in particular to look at the problems of tort liability. Now, David Lewis, in between, came out and said, well, this is all really getting confused. We have to understand causation in a much more clearer way, and basically his claim is that causes counterfactual, causation is covered by counterfactual test, which we call the but-for test, also used in legal theory with that name, that simply says that C is a cause of E if and only if E is counterfactually dependent upon C. That is to say, but for C. So if there's an alternative possible world in which C doesn't occur, E would not have occurred. Sufficiency condition. This account departs from the regularity thesis, David Lewis arguing that regularity theses don't really make sense, that all causation is singular. And this comes under the term proximate causation in legal terminology. Okay, so that's roughly where the world is. It gets then really complex because the new developments, there are some new developments. One is the probabilistic approach. The basic idea that C is a cause of E, if the occurrence of C raised the probability that E would occur. I'll get to all the problems that arise now with all these conceptions, or why one is developed over the other afterwards. And this approach is applicable to both regularity and singular accounts of causation. So probabilistic account says we don't need to worry about that distinction here. This has the advantage as well that it provides a natural metric for the quantification of causal relations. That is, C1 has a causal impact on the emergence of E of degree D. Okay, now I just want to quickly refer to the contemporary debates that have come up now. The first is, I'm going to reverse the first two bullet points on here, is what I call puzzleology, taking over from the philosophers' preoccupation with what are known as trolley problems or trolleyology. The literature is extremely intricate and complex with regard to developing we're looking at solutions for problems of causal overdetermination. And there are three kinds of overdetermination. There's simultaneous, preemptive, and iterative causation. So simultaneous causation is the case of the two assassins shooting the victim at exactly the same time. They both, in each case, and it's not a question of perception, in each case we have all the evidence to show that the bullets entered the brain and fatally at exactly the same time. Now, when you apply the but-for test, the counterfactual test, you have a problem. Because but for the first assassin shooting, so you switch assassin 1 off. So he doesn't shoot. Well, the victim is dead because of assassin 2. But if you say but for assassin 2, therefore assassin 1 is not the cause. Oh, sorry, not the assassin 1 is not the cause. His behavior, his action, the event, pulling the trigger. So we have to describe an event space of basically of all the actions together, what we call shooting or killing or whatever, is picking up the gun, aiming, putting your finger around the trigger, pulling it, and so on and so forth. So but for that combination of events, he's a cause if the victim wouldn't be dead. But he is dead because of assassin 2. Apply but for test, the counterfactual test to assassin 2, we have the same answer. We then result with the counterintuitive problem that but for, with the counterfactual test, but for assassin 1, but for assassin 2, the victim should be alive, but he's dead. We would then have to then say there's no cause. Now, David Lewis remained hard on this particular point and was refusing to give up on it. The Nest test solves this in a different way. Nest test, or Einer's conditions, simply says necessary element of a sufficient set. So there are two sufficient sets. There's the set of events, of the first assassin, A1, and doing all that, pulling trigger, etc., in that set is sufficient for is sufficient to make that, is necessary, sorry, to make that set sufficient for the death of victim. That is to say, if you remove that element, that is the pulling of the trigger and so on and so forth, out of the set, that set is the null set, and that is not sufficient. Now you can apply that to both, and then you'll find that both assassins are have caused causal factors. Both are have caused the death of the victim. The argument that counterfactualists would simply say, well, that doesn't give us really any clarity. Both killed him. That's useful for allocations of legal liability, responsibility, but it doesn't really tell us about causation per se. While the arguments, those who support to take Mackey's position and Richard Wright's position, so but this is simply nested counterfactualism. Okay, then there's the other cases of preemptive causation, and that's simply the case of I throw a rock at the window, and Kaisen throws a rock directly after at the same time or just after me, and my rock goes through the window. His rock follows mine through the window. But had I not thrown the rock, the window would have smashed through Kyson's rock. Therefore, my my smashing the window was not a cause. Again, you see the same thing unraveling. And then there's the cases which I think are the most important for neuroscience, those cases as well, or all problems of overdetermination are the what are called iterative causations. And that is the case of medical drugs. I was reading up on particular SSIs or neuroleptics or whatever they're called, which now can be developed that are in a retarded form that release slowly into the brain. And now we have the particular cases that there's you have a quantity of a drug given to someone who's got, say, schizophrenia, is to help them reduce the hallucinations. The first molecules are released, okay, and it's released in enough, sufficiently to stop the hallucination, but then again, it keeps releasing. There's more and more and more rocks. So the difference between the iterative case and the preemptive case is the preemptive case concerns two events, while the iterative case is just the continual release from the same source of the same chemical or other event, so to speak. And the question is, which one of these sort of molecules is the cause for the stabilization of the patient's behavior? And now there's the other area that's being discussed is what actually constitutes a cause or a causal factor. Is it only physical and physical? Is that this behavioristic approach that again we saw, which Conrad was setting out, that there's this kind of the claim being that causation literature focused too much on behavior and there are other things that are going on. So philosophers are asking whether there can be physical events, such as mental events, beliefs, states of mind, so to speak, that may not be easily representable by, unless you believe in the complete reductionism, states of mind which you may not believe that are representable by brain states. So can mental events, can our beliefs cause something? That is a big discussion in philosophy at the moment. And the other one, which I haven't put on the bullet points here, the other is measurement issues. So if we're not using a probabilistic approach, is it possible to measure causal impact and so on outside of the probabilistic mechanism? I myself have worked on that, and that's how I discovered Klaus's work, because Klaus applied in his work the Shapley value to modeling causal impact of brain processes. Now, this is an interesting point, is that Klaus's application of the Shapley value is both satisfies both, or rather can be incorporated in this Ness-Einus condition, and it is also can be interpreted probabilistically, because the Shapley value has a probabilistic interpretation, but it also has its own non-probabilistic interpretation of how you want to look at it. But the idea basically under the Shapley value is you have some outcome, some system that switches from A to B, switches on and off, and there are prior events lining up, all of which could be sufficient in the specific order in which they become pivotal. So you have E1 to En, and they all believe that they're lined up in a row, and E1 doesn't change the system, E2 doesn't change the system, but E3 does change the system. Okay, so then E3 changes the system, but then you can think of another permutation where E3 is the first one, and so on. And that can be given a probabilistic interpretation, but it can also be given a parametric interpretation under the Einus and Ness conditions. Okay, that's, I just would like to say is that actually everything that was really nice to follow up on this, so Conrad was saying, can actually be brought together under different conceptions of causation. You just have to really be specific about what you want to do. So the idea that you want to look at down the brain, you say, well, we want to isolate this particular part of the brain or this particular process. We can say that we don't need causation, but equally we could equally say as well, actually, it is too complex, but we're going to reduce it to a simple model of which causation under a counterfactual, a nested counterfactual, under a probabilistic, then apply Bayes nets and all the other things can be applied. So there's the work of Judea Pearl and Halpern in particular who have pursued this approach. Okay, I hope that's clarified what we've been talking about, and that when we're talking about neuroscience and causal models in neuroscience, that the most important thing is not simply to say no causation or all causation, but to understand that there's a concept of causation, and there are particular conceptions of causation which may or may not be applicable. And I think that one can be pluralistic in our approach to the phenomena that we're analyzing with that, and not having to be dogmatic about sticking to one or the other. Thank you.
Thank you.